Let's take a closer look at braking in MotoGP, what types there are, and how much control the rider has. First of all, there are three types of braking force that every bike has. The front and rear brake, which are controlled by the riders, and then the engine brake as well. As we can see, the front brake takes on the majority of the workload with 70% total braking force. The engine brake accounts for 20%, and the rear brake, meanwhile, only accounts for 10%. The front brakes are 100% rider controlled and features two carbon brake discs and brake pads, important when stopping from over 320 kilometers an hour. The engine brake is controlled by the wheel and the electronics, meaning it's variable per corner. It doesn't have any rider input, and it's all down to bike and ECU. Finally, the rear brake. It only accounts for 10% of stopping power, meaning a steel disc is suitable. It's 100% rider controlled, and riders can either use a lever on the right foot or a lever on the left handlebar. In the end, it all comes down to personal preference.
Typically, when approaching the corners, riders have two options. They can choose speed and try to outrun their competition, but risk sacrificing accuracy and control, or they can rely on the brakes and corner as tightly as possible, but lose speed. As we can see, the Movistar Yamaha bike is cornering at high speed, using progressive turning. Releasing the brakes early carries much more speed through the apex, but having a much wider angle through the corner, whilst the smooth throttle on exit helps to maintain a good speed. The Repsol Honda bike here, meanwhile, squares off, relying much more on brakes and acceleration of the bike. The rider releases the brakes later and accelerates hard out of the apex. The Movistar Yamaha rider takes a much wider racing line, going faster through the apex, giving him more time to lean and needing much less grip. The Repsol Honda rider, on the other hand, uses the fat part of the tyre, needing more grip for the tighter angle and timing the lead more precisely. Both types of cornering have their moments, and while some riders and bikes favour a certain style, a rounded rider will be adept at both. Let's take a look at downforce and top speed in MotoGP and some of the trade-offs that must be made when deciding whether to ride with or without the aerodynamic fairings. Top speed can only be achieved when the riders open up the throttle. Depending on whether they're riding with the fairing depends just how fast top speed is. The standard fairing allows for a higher top speed and greater agility. This has to be weighed up against reduced stability when braking. The aerodynamic fairing, on the other hand, provides more downforce, reducing the wheelie and increasing the front tyre contact whilst improving stability when braking. The shape of the fairing can have a significant impact on the drag, which can be used to the rider's advantage. The standard fairing creates less drag and creates less downforce, which could lead to more wheelie when accelerating. The aerodynamic fairing, on the other hand, creates more drag but directs it to keep the front tyre on the track. Ultimately, it's the aerodynamic fairing that keeps the wheels in contact with the asphalt for greater acceleration, whereas the standard fairing allows the rider to reach a greater top speed. Let's take a look at what the steering damper is and what it does on a MotoGP bike. The bikes in MotoGP have a short wheelbase and aggressive steering geometry, which is great to help the riders change direction quickly, but can cause instability, uncontrolled movement and wobble when accelerating. The steering damper is connected to the handlebars and the front fork and stabilizes the steering, preventing uncontrolled movement. The damper can be adjusted to suit the rider's feeling, giving them more or less damping, making the bike more or less reactive to sharp steering movements. With less damping, the bike steers more freely. The rider gets more feedback from the bike, but that can also be a downside as the stability decreases. When accelerating, the rider has much less control of the bike, which could lead to wobble with serious consequences. With more damping, the rider has to work more to steer through the corner, but gets much less feedback. More damping does, however, provide more control and reduces the risk of wobble when accelerating. Tracking of a MotoGP bike, how it works and what it can do. GPS positioning is not allowed in MotoGP, but there are other ways for the bike to identify its location on a track. Using onboard sensors, the bike can measure how far it's travelled. The sensors then transmit information to the ECU, which is reprogrammed for each race and each track, and so can use the data to reset at different points and different sectors on the circuit. The bike location can be used for corner-by-corner electronics, where the ECU will deliver settings best suited to the corner that the bike is on, controlling things like engine torque, traction control, engine braking and anti-wheelie. These adjustments in the electronics can greatly help the riders to get the most out of the bike at each point of the race, especially when decisions need to be made in hundredths of a second. Take a look at oversteer and understeer in MotoGP. What is it, what's the difference and what does it do? Understeering and oversteering are ways of manipulating the bike throughout a turn. Riders can adjust their steer angle, oversteering or understeering to compensate for speed or to line their bike up for the next section of the circuit. Understeer is when the side slip of the tyre is greater than the rear, pushing it away from the turn. Here the front tyre has significantly less grip than the rear tyre. The problem with understeer is the risk of running wide as it's hard to turn and correct. Sliding the front wheel increases the wear on the tyre and the rider could risk crashing. Oversteer is the opposite and is much safer, when the rear tyre slides out away from the radius of the turn more than the front wheel. The front tyre maintains much more contact with the asphalt than the back. Oversteering can help the rider with turning, keeping them tight into the turn and straightening out from the apex faster using the throttle and electronics. The bike's traction control can help riders recover their control of the bike and avoid crashing. Let's take a look at the front springs of the MotoGP bike, how and why teams might change them and what the effects can be. Common suspension rates in MotoGP go from 8.5 newtons per millimeter being the softest up to 10.5 newtons per millimeter on the harder end. MotoGP riders may choose to have a combination of spring stiffnesses in their front forks. The stiffness of the springs is crucial because if the front shocks are too soft, the bike risks dropping too far forward when the riders hit the brakes. On the other hand, if the springs are too hard, the pressure from braking gets transferred onto the front tyre and causes a lot of wear very quickly. The front fork is assembled as a single unit and the two springs work in unison. The teams can change the springs really fast, typically taking less than 2 minutes. Riders can choose to combine springs in the front fork to achieve a more precise overall stiffness. That's how and riders choose their suspension stiffness in that front fork. The exhaust systems on a MotoGP bike, how they can be modified and what the results of those changes can be. The exhausts have two main purposes, firstly to remove the waste gases from the engine and also to draw air and fuel into the cylinder for burning. Believe it or not, but the exhaust can have quite a profound impact on the performance of the bike. It can increase the power within rev ranges. As a result, this can change the throttle feel for the rider, making the throttle more or less smooth or sensitive. The length, width and even the shape of the exhaust can be modified, affecting the flow of air and gases to and from the engine, allowing more or less exhaust fumes to escape faster or slower and increase or decrease the back pressure and upstream. Exhausts are made from a titanium alloy that's extremely heat resistant. This is important because at high speed, exhaust gases can reach 1,000 degrees Celsius. MotoGP teams are allowed to change their exhaust throughout the season and so can use this to adapt the bike from circuit to circuit. Wheel spin in MotoGP. The rear wheel is what drives the bike, giving it acceleration and propels it forwards. There needs to be a speed differential between the front and rear wheel, so the front wheel spins slower than the rear wheel, or the rear wheel spins faster than the front wheel, whichever way you want to look at it. This is why we get that forward push. If they were both going the same speed, we wouldn't be pushing that front wheel. As a result, the speed of the front wheel is the true speed that the bike is going. Specifically with slick tyres, to get that forward thrust, the rear wheel needs to spin around 8 to 12% faster than the front wheel, depending whether we're on a straight, accelerating or cornering. Also the grip level and the tyre softness. Let's take a look at an example. If the bike is travelling at 330 km per hour, the front wheel spins accordingly. The rear wheel, however, is spinning 12% faster at 369.6 km an hour, so we get that forward thrust that we've been talking about. And that's rear wheel spin in MotoGP.